it's appropriate, and I'll try and answer them as best as I can. Okay, Susan, are we ready to go, do you think? Okay, I think I'm going to go for it. Right, so welcome everybody. Today's workshop, we'll be talking about our curriculum, the DBIS approach to mathematics, helping children develop growth mindsets, and how to support your child with learning at home. So the first thing I wanted to talk about is our curriculum. So at DBIS, we follow the English National Curriculum, which is available on the internet. You yourselves could just go and Google the English National Curriculum. And we will be talking about how Year 3 and 4 teach through units and Year 5 and 6 teach through concepts. After this meeting has taken place, we're going to be uploading this to the hub, and there will also be a link to our full curriculum there, so you can look at each of your individual year groups, the year group that your child is in, and you can see the objectives that are being taught for them. So if we start with Year 3 and 4, Year 3 and 4's mathematics curriculum is split up into these strands, which you can see at the top here. And generally, we will follow this path. So we'll start with number and place value and finish at statistics. But, for example, when teaching fractions, you might recap on multiplication and division and addition and subtraction. They aren't standalone. We will recap on those units that happened previously, but also the units to come. The units are taught for a number of weeks. Some units are longer than others, and links are made to previous units to build connections. Children may demonstrate more confidence in particular strands and units, and that's completely normal. Here's just an example of the kind of activity you might expect, and this is from Year 4. It's a rounding activity, and the children have been asked to round up these numbers here, and then recognizing that they are able to round to the nearest 10. Okay. So moving on to the Year 5 and 6 curriculum. Again, we do use the English National Curriculum, but it's slightly different. So although we do have these strands from which we take the objectives, what we actually do is we combine some of the units together. So I'm going to show you what that looks like on the next slide. Units are revisited throughout the year. So for example, we might do addition and subtraction at the same time as teaching number and place value and percentages, because we might be studying estimation, for example, and that would link to statistics too. But then it might be in the next unit that we go back and link to number and place value again, fractions and geometry. So we just see more connections when we build up to Year 5 and 6. So this is a new approach that we're taking to teaching mathematics in Year 5 and 6. And this is called conceptual learning, where we're discussing key mathematical ideas. Right, so just on this slide here is an example of a unit that we're teaching at the moment in Year 6. And it's called Y base 10. So Y base 10 combines some different units. So it's got number and place value, it's got decimals, which comes from the fractions, decimals of percentage unit. It's got addition and subtraction and statistics. So all of those units are combined to teach Y base 10. Turning your microphone off for me, please. Sorry, I can't see who it is. Okay, sorry. And then here's an example of an activity which actually combines two of these units, statistics and number and place value. So the children had to look at a table here, identify how many migrants there were in the world in 1990, for example, work out the value of the 3 in that number. So we're looking at reading bigger numbers. And then at the end, what have you noticed about the number of migrants? So we're asking them to interpret data, but at the same time, check their understanding of place value too. Okay, so that's our curriculum. Although we do have different approaches in terms of teaching conceptually and teaching through units, the actual way that we teach the maths is still the same for Year 3 to Year 6. So the first thing we'll do with every year group is that we do a pre-assessment. Now, this is not something scary, it's not anxiety-inducing, it's just a way of checking what the children already know. So it's to gauge their confidence and their understanding. We don't normally give them much warning about this, it's just something that we do, say, show us what you know. And this year, we're trying to make the activities more fun and look less like a test. We'll then deliver the unit itself, and we might recap on previous unit topics too, and throughout that there'll be opportunities to check progress for the teachers. So we'll be delivering activities, they might be posting work to Seesaw, they might do collaboration tasks, and there'll be projects too. So after they've completed the unit, to check their understanding, to work out how much learning has actually gone into their long-term memory, we will then take a post-test, but we wouldn't do that immediately after, because if it's immediately after, the learning is in their working memory. So it's just a case of remembering what they did recently. So actually, we want to do it 2 weeks after the unit to check what they fully understood. So what we'll see what learning has taken place 2 weeks after, and then we can make a comparison between that pre-assessment and the post-test to see how much progress that child has made. But at the same time, we also check progress throughout that unit. After the entire unit has taken place, and perhaps after a few units have taken place, they would then do an end of topic assessment, where we see them make connections and do more problem solving. If we find in the post-test that the children haven't quite grasped something, that isn't the end. It's not, okay, they didn't get it and that's it. We would then revisit that within the next units to make sure that we are closing those gaps and checking where the children have misconceptions, because it's often a shared misconception that we can address throughout the further units that we are teaching. Okay. So we've now spoken about the curriculum that we are delivering, and now I wanted to talk to you about the DBIS approach, because I don't know about you all, but maths is actually very different to the way I was taught. So when I was at school, we got taught to rote learn. We got taught that timetables were key, they still are, but we also got taught just to do it quickly and to do it accurately, and it was all about formal written methods. But as you all know, everybody has a calculator. Everybody has a phone now, and there is a calculator there, so it can do it for us. So maths is actually a lot more than just being able to do fast written calculations. So I'm going to talk a little bit about that and hopefully address some misconceptions about maths.
I butt in there? Yeah. And I think that's a point that's worth coming back to in that fast, repetitive understanding and that speed that's involved in mental maths is useful to a point, but it can also be very counterproductive, especially with groups of girls who potentially lack confidence in maths. And what the research will show is that sometimes those less confident learners will struggle to do things quickly, and therefore actually then be much more reluctant to try and challenge themselves in other areas of mathematics. And it isn't because they haven't got a good mathematical brain, it's just that speed of recall and really fast recall isn't something that actually helps them learn. So there's a balance always between learning of the timetable, because it's like learning to drive, isn't it? Once you know your timetables, you know them and you can use them. So you're using your mental capacity to actually solve the problem rather than remember the times table. But that quick recall and that quick being able to solve the problem quickly isn't always the best focus. It's one focus and it's something that's important, but it's not the only focus. And that's, I think, quite different from certainly when I was at school.
Yeah, I totally agree, Susan. And actually, we'll go on to that later. We'll talk a little bit about the fact that maths is that the highest achievers in maths aren't the children that do things fast and first. It's actually about being creative thinkers and seeing patterns. And that's the opportunity where those children who might feel they're a bit slower can actually feel like, yes, I get it, finally. And we'll talk a little bit about that in maths, we want every child to feel successful, and that will build their motivation. Okay, so in terms of knowledge, there are actually 3 types of knowledge that we focus on within maths. The first is that factual knowledge, the retrieving facts from memory, the things that we know are important, the times tables, the number bonds, the quick additions, the quick subtraction facts, the multiplication and division. But then moving on from that factual knowledge is also the procedural knowledge. So actually knowing what you need to do to solve a mathematical problem. So working out what's being asked, deciphering the problem, and then working out which operation to use and then executing it. Then the final type of knowledge that we look at is conceptual. So actually understanding concepts and relationships between concepts and then linking them together. So procedural and conceptual learning is bidirectional. They kind of work together. And then factual is the basis from which we can then build the procedural and conceptual. So you do need some basic number bonds, the basic number facts to help complete the procedural and conceptual activities and to build that knowledge. But at the same time, we want to build the understanding that actually it's not all about retrieving facts from memory. It does help, but it's not the be all and end all. There's a lot more to maths than just that. Okay, and actually what's really important is understanding that the world looks very different. I mean, it looks really different this year. It looks very different to previous years. And we now have to understand the 21st century learner attributes, what we want from the children, what we want for the people in our workplace, what we want in terms of society. And it's not necessarily about quick thinker. Well, it is quick thinking, but not about being fast adding numbers together. It's also about collaboration. It's about being able to reason and critique, to be able to be creative and to question. And they're the skills that we want to build within mathematics too. So we want our children to experience success in maths. So just here, I've got an example of a year 6 activity with a child. I've said, yes, you've got it. How did it feel when it worked? And then she wrote, it felt very satisfying. I was just playing around. I didn't know I got it. So this is actually a child that doesn't feel very confident in maths. And she didn't even know that she was getting it right, and she did, and then she was really happy about it. And with maths, if we want children to be motivated, we need them to get the wins. We need them to feel successful, and that will build their confidence. The other thing that we need to do is build a range of strategies, knowing that there isn't just one way to do things. There isn't one way to represent number, and there isn't just one way of getting an answer. There might be a way that you think is best, but then your child might have another way that they think is best. And it's building an understanding that there is more than one approach to things. And you can have those discussions, and I will share with you a link to our calculation policy. It's going to be updated, but it's got some examples of the way that we teach at DBIS, but it also opens those conversations about the way that you might have been taught and how it might be slightly different to the way your child has been taught formal written calculations, for example. But I know, looking at number, I never saw numbers represented like this when I was at school. And these are kind of new approaches to learning in terms of representing numbers. We've got a part-whole model here, we've got a bar model, and we've got a counter representation here. And they're all showing exactly the same thing. It's just the number 130,500, but written in different ways. We also want our children to make sense of problems. So word problems can be tricky for children, and it's deciphering what the question is asking and what operation to use, how many steps are there. So this is just an example of a word problem here that a child's had to solve. And transferring knowledge is another part that we really want our children to focus on. So an activity might be, rather than doing a lot of written mathematical calculations, it's just really absorbing knowledge and going, okay, what have I learned today that I didn't know before? And can you ask questions? So an example, we looked at number systems from around the world and how they were different. And by looking at number systems around the world, it really deepened their understanding of how successful base 10 was. So base 10 is the place value system that we use in society. And they were going, oh, actually, base 10 is pretty simple. And before, I think they thought it was quite confusing. So when they realized that around the world, people use systems like base 27, which was very complicated, and that they were using all the body parts to count, they then realized, well, the question here was, these different number systems will stay and thrive, or will new ones grow too? And then we had a whole discussion about how a number system comes about, what makes it sustainable, and how we understand it. And we've built our full understanding now of what base 10 actually is, because before, I think we just took it for granted that, okay, we put the ones here, we put the tens here, and we put the hundreds here, when actually having this conversation built a greater understanding of what our number system is and how it works.
I think that's another key point, isn't it, Katrina? Because I think one of the other ways maths is so very different now is that it's so talk-based. The importance of being able to talk through your thinking and justify your opinion, and actually an area that some of our higher attaining children find most difficult is explaining and hypothesizing and proving why they believe their answer is the correct one. And asking a question as simple as, is that the only answer, can really throw a child as well. So that whole opportunity for talk within mathematics, we talk about writing all the time, it makes a lot of sense. But it's just as equally important in the teaching and learning of maths that children have the opportunity to ask those questions of each other and be able to justify why they think their answer is correct. And I think that this sort of question ideally shows how that works.
Yeah, perfect. And I think Susan knew exactly what I was going to say next, because the next one is explaining mathematical thinking. So we do ask the children to explain their mathematical thinking. And what we don't want the children to do is go, oh no, it's English. Actually, understanding that maths does involve explaining, and that mathematical thinking doesn't necessarily have to be fully worded. It could be that they use symbols, they use diagrams to explain how they've come about with their answer. So there's just an example here, and there's a full explanation here, which has been done very well. But with the second one here, rather than doing an explanation, they've just shown all the different number opportunities that could go here. And then in this other activity here, oh, sorry, I feel like that one moved out of the way. Yeah, again, seeing patterns. So again, we were combining statistics with place value, and we asked the children, what do you notice about the migrant population of Hong Kong? So it wasn't merely, can you decompose these numbers? So we got the children to have the number, and they're big numbers, for example, 2,838,665, and we got them to decompose them, break them down into their different parts, just to check their understanding. But then at the same time go, well, what's this number actually doing? What is it saying? And I think that's really important, and something I would really encourage at home is that everyday mathematical language, the everyday use of number, and the children have an understanding of how big these numbers really are and what they mean. So seeing them in the context of news, for example, talking about the news, talking about statistics, what does it mean? What do these numbers show? Because once children are surrounded or immersed within number, they have a better understanding of it. So that's in terms of our approach to mathematics. And the next thing I wanted to talk about was growth mindsets, because at DBIS we encourage and we instill the values of growth mindsets, and I'm hoping that at home the children also are developing their growth mindsets too, and that's really important. We want to normalize mistakes. I think sometimes maths can be seen as a subject that can bring about anxiety, because people have often seen it as a subject of right or wrong, and that's actually not the case. As Susan was saying, there's more than one right, there's more than one answer often, and explaining your thinking and explaining how you got there is really important. And we want the children to realize when you make a mistake, your brain is actually growing. It's really important, and when you make a mistake, you can learn more and you can challenge yourself. So that's also something I'm going to talk about. And the last thing is flexible groupings. So, growth mindsets, barriers to learning. It's really important in maths that we understand that children do have barriers to learning. There are things that put them off. There are things that maybe hold them back and go, oh, I can't do this. And we need to understand that that's the case, but help reassure them that they are going to be able to get it. And often with maths, it's just the amount of time that they need. Children that find maths tricky, or children that find concepts hard to understand or grasp, they just need more time. And the same can be said for those children that really get it quickly. They just want to move on fast. And we need to make sure that they've had the time to think through and to think deeply about the mathematical concepts that they're studying. So the first thing is poor motivation. Children need to experience success. So this is something I spoke about before. And success equates to confidence, which equates to motivation. And if you find at home that your child doesn't seem to be motivated with maths, it may be a case that you need to talk to the class teacher, because that class teacher can ensure that that child feels successful within the classroom. It might be that the homework needs adjusting. Not necessarily so it makes it a lot easier, but just so that child begins to feel like they can achieve. And once they start to feel like they can achieve, that motivation will come, that confidence will come, and then they'll feel less apprehensive about math lessons and build that confidence to go, actually, I can do this. So the setting, oh, sorry, go ahead, Susan.
Sorry, I've interrupted again.
Okay, go ahead.
One of the ways of doing that, of course, from a parental perspective, is to ask the child to teach you. So if you're sitting with them and they're doing their homework, if they can actually explain to you why they're correct, or you suggest you have a go and you do it incorrectly, or give them an answer that isn't right, them having to actually explain to you why it isn't right and where the mistake was will really support that transfer of knowledge and that deeper understanding that Katrina's talking about.
Yeah, totally agree. And that's that win, isn't it? So you get that win and they go, oh, actually, I've just had to explain something to mum or dad. Makes them feel good, makes them feel motivated, and then they'll have the confidence to carry on. So the second point is for the children that say, oh, I'm rubbish at maths, you need to reinforce that they are not. Success is changeable. There will be times where you feel like things aren't going your way or finding things a bit tricky, but then there will be other tasks where you feel more confident. And it might be the case that you just say, okay, we just need to spend more time going over this. Or, yeah, can you explain? Or can you tell me which part you're finding tricky and we can work through this together? Another question that they might ask is, why are we doing this? Or why do I have to do this? And in terms of homework, is to build that understanding and explain to them that the more we understand about maths, the more we understand about the world. And I think the children are beginning to grasp that, actually, that maths is all around us and it is really important. And the last thing, I can't do this. Okay, if the children say, I can't do this, add the word yet. So encourage hard work and perseverance. Don't go, okay, we'll leave it to tomorrow. these kind of phrases could work. You're working very hard on that. I'm sure you learned this, but I'm sure I learned this, but I've forgotten. Can we both look at it? So that links back to Susan's point. Okay, I think I might know, but I'm not sure. And then they might feel more confident to go, oh, I can tell you this bit, and then you work the rest through together. And also being, okay, I'm sure you can get this if you keep going. Let's have a go together. So rather than going, okay, yeah, I'm not a maths person either, because that is not a thing. Going, actually, yeah, we can do this together. Let's see if we can solve this problem. And of course, if those barriers to learning do seem to be coming all the time, then do seek support. Talk to the class teacher and they will help you to ensure that the child does feel more motivated and then they feel that they can find success within maths. Okay. So in terms of growth mindset, we already talked about making mistakes. So we want children to feel like making mistakes is completely normal. They should be celebrated. Making mistakes is part of the learning process and it's going to help you develop a growth mindset and you need to be challenged. If a child is getting something right every time, then they aren't learning anymore. So it's really important that they deal with facing difficulties and things being a bit of a struggle. We need to address the fact that mathematics, as we already talked about, is not about procedure and calculation. It's more than that. It's about creativity, making sense of maths, connections, and communicating ideas. So if children feel like they're slow, or even if, to be fair, the opposite, children feel like they're really quick, it's really enforcing that idea that actually being quick isn't the be all and end all. It's being able to understand why and how, being able to explain your thinking, and being able to explain to somebody else is really important, which links to our flexible groupings even. So we've moved away from soft streaming this year, and it's proving really advantageous already. This means that the children can work together. They can explain their thinking, which deepens their understanding. They can learn maths from other children's perspectives, because sometimes when you're around children with the same ability and that's it, you have one fixed perspective of something. When you broaden that understanding and you have children of varied understanding levels, they start to see maths in a different way. We've done work recently where children would say something you'd never even considered. Go, actually, that's a really interesting way of thinking about it or looking at it. And that builds that conversation, builds that understanding, the communication, connections, and actually creates a really exciting classroom environment. If a child, when they're on the carpet or if they're during an introduction, they've really grasped the concept quickly, it's not that they're going to be held back until everybody else gets it. We will move them on and we will extend them, but it's just an opportunity to share understanding in a really comfortable environment where everybody feels like they can succeed. So flexible groupings are really advantageous. And another thing to point out, actually, is that because we're not tied down to just going to your maths class and coming back, that if a child does need support, they can actually receive that support within the school day at any point. So it might be, 5 minutes in the morning, let's just go over this thing, or, right just before the end of the day, oh, let's just quickly go over this. And then they be like, oh, I got that. And rather than going home and going, I didn't really get maths today, we can actually get those interventions in quick to close those gaps and so children feel more confident. And then the last thing I wanted to talk about is maths person. I think I have this too, saying I'm a maths person or I'm not a maths person. And it's funny because we don't really say that about English, but we say it about maths. And I think we don't want that label. We don't want to say you're a maths person, you're not a maths person. We are all learners together and we are all capable of learning maths. It's just that some of us need more time, and that's really key. So I'd really encourage you to develop growth mindsets at home. You might already have them already, which is fabulous, and encouraging your child to develop a growth mindset too. Okay, so the last part then is about how you could support your child at home. So we're going to talk about the growth mindsets, what you can do, real world connections, and then the online platforms that we have that deliver some of the programs that we are teaching. So key thing, so with all these pyramids, we're going to start at the bottom. So the first thing is modeling a positive attitude towards maths. So if your child sees you saying, oh, I'm not a maths person, or I didn't find maths easy at school either, that doesn't really help. So what we want to do is model a positive attitude towards maths. As Susan talked about earlier, it might be to go, oh, that looks a bit tricky, or can you explain that to me? Or I was wondering how you did that. Show an interest in what your child is learning, and they hopefully will then be motivated and have the confidence to explain. The second thing is to avoid rushing. Rather than giving the child the answer to a calculation, which is the easy way out, and it's quite a natural thing to be doing, if I'm completely honest, because as teachers, sometimes you do just want to get to the answer and you have to go, no, take a step back, tell me what you understand, or which part, we have to work out which part they're finding difficult, and then help them through that journey before they find the answer themselves. And then the last thing, so if you've modeled a positive attitude towards math, and you've avoided rushing, and you've tried all the other growth mindset things that we've talked about, you can seek support. You can talk to the class teacher. And then we do have a calculation policy available to you if you just want to brush up on any of the formal written methods that we now use. As I said, there is more than one way of doing things, and different representations. There may be different representations that you haven't actually seen before. So the calculation policy is linked within this set of slides, which will be shared on the hub, and that should prove very beneficial if you wish to take a look at it. Okay, so what I thought I'd do is I just talk about each individual year group and giving you 3 things that I think would be really helpful to support your child at home. So if your child is in year 3, 3 key things that would be really useful. The first is actually being able to use a ruler. Even just to draw a straight line can prove very difficult. I know teaching in year 6, that can still be a struggle. So being able to use a ruler and actually being able to accurately measure, to being able to read a ruler, the units on the ruler, and work out what they mean. The second thing, regular times table practice. It's actually expected by the end of the year 4 that children know all of their times table up to the 12 times tables with quick instant recall. So if we get that in year 3, that is really beneficial. So the way that the children can do that is in any way that you think would be most beneficial, but at the same time, Times Table Rockstars, which I'll share with you later, is a really good platform. It's gamified and the children do really enjoy it. And the last thing is try to use operations in daily activities. Normalise the use of addition, subtraction, multiplication and division. In year 3, we'll be focusing more on addition, subtraction, but for example, shopping. It might be that you ask them to work out, okay, I've got these 2 things here. Can you tell me how much that will cost? And see if they can work it out. So build those mental math strategies to help them check their understanding of addition and what works for them. What's the quickest way for them to work out the answer to a problem that you've asked them to solve? Okay, in year 4, the 3 main things, these are kind of new ideas or concepts that are more, that are studied more closely in year 4. The first being written strategies for addition and subtraction, just feeling really confident in how it works. Using 3D shape vocabulary names. Up to year 3, really, we use the basic 3D shape vocabulary names, but we then have an increased number of shapes to learn when they get to year 4, and using fractions in everyday life. Oh, I'm sorry, back to the 3D shape vocabulary names. When we add the curriculum map, there will be the 3D shape names that are covered within year 4. And then using fractions in everyday life, because fractions are a concept that children can find very hard because they see it as very abstract. They don't always relate to it. When actually, if you just talk about it within the context of food or in the context of sharing, it can build that understanding. They can make connections. So for example, if you're saying, okay, I've got half a cake and you've got a quarter of a cake, how much is that all together? Now, that does seem very tricky, I know, but them understanding that that doesn't mean, because some children, what they would do is they do half, add a quarter, and then they would get a sixth. Well, actually, if we think about a sixth, that is smaller than a half and a quarter. And then knowing that that doesn't actually make sense and seeing it visually really helps the children. Okay, so those are the 3 top tips for year 4. And in year 5, 3 key ideas: using negative numbers in context, so perhaps in the context of weather. Now, I know that we don't have negative temperatures in Hong Kong, but it might be worth talking about negative temperatures in other climates. The second one is check their understanding of telling the time. Now, I've realised, speaking to parents, that not all of us have analog. I don't even have an analog clock in my home. And the children actually getting used to reading analog clocks, knowing how the 24-hour clock works and the intervals between different times, knowing how many hours there are in a day, knowing how many days there are in a year, knowing how many weeks there are in it. All of those kind of things that we perhaps take for granted are things that the children perhaps don't encounter as regularly as we did. So it's worth checking with the children that they have a full grasp and understanding of telling the time. And the last thing is timetables, not times tables, timetables. For example, like a bus timetable. having an understanding of how a bus timetable works and the difference between each time being the duration of the journey. So understanding how long the journey is based on what they see in the timetable. Now, I actually think in DB, the children are quite used to seeing timetables because of the buses, and many of them take those buses. In fact, many of them take them without an adult. So they're used to being able to read a timetable. So it's just worth having those conversations with the children to check their understanding, see if they've fully grasped how they work. So that's year 5. And then in year 6, encourage links between decimals, fractions, and percentages. So build that understanding that these 3 things are connected together. They all represent parts of a whole. Number 2, have a go at using a protractor. It can be an interesting process, and it's something it's worth exploring with the children. They will use them in school in year 6, but it's quite nice to actually use them at home first. The children have that confidence, go, I already know how to use this, because then they could be the person to model to the rest of the class how they work. Because I know as a teacher in year 6, we spend a lot of time, and there's lots of variation in how we are able to read a protractor or even place it on a straight line. So that would be something as a year 6 teacher that I think would be very beneficial for the children. And the last thing, which will then link onto my next slide, discussing statistics in the news, actually having conversations about maths in the news, our understanding and interpretation of what we see and what it means. Now, obviously, we have a lot of morbid statistics about COVID. It might be that you want to look at other areas of interest or topics to discuss statistics, but it's definitely something worth doing. Now, the last thing is if your child is working at a very high level within year 6, I've just added a link here for something challenging, and that takes you to the Primary Maths Challenge website, and there's just some resources there if you're wanting to really challenge your child. It's just an option if you would like. Okay, as I said, again, this will be on the hub, and you can click on this. It will be a PDF, and the links will be clickable, and you'll be able to go on those and then explore yourself and discuss with your child if you wish. Okay. So the last 2 points relating to how you can support your child at home. The first is just normalising maths, seeing it as something that's not just a subject at school, it's something that's all around us. A really great way and fun way to do this is playing board games. Board games involve a lot of maths. I played Catan actually recently, just last weekend, and it was a really great game because you had to barter with one another, you had to trade, you had to be able to count, and you had to be able to do it with distractions, and it's a really great game, and it involves you using a lot of different math strategies all at the same time. So board games are really great. Encouraging your child to have ownership over paying for things themselves. Now, it doesn't mean that some of you might be encouraging to earn their money at home, but even just giving them the money and being with them and asking them to pay for it, so they get used to that transactional way of getting change, receiving change, and giving the money over, so they understand the value of what they are getting for their money, and also even getting them to estimate how much it's going to cost, so they get the money out of the purse. So they go, oh, okay, I think I'm going to need $100, and then realizing actually it's 150 and having to come back. So that all of those things kind of link together. So estimation, addition, subtraction, and a value of money and understanding of the wider world. Baking.
From the parent perspective, I think that link with money is so crucial. So many of our children do not ever handle money. They're used to being given an octopus card, or they have a watch with an octopus card in it, and their transactional knowledge is virtually zero because they don't see money changing hands in the same way that we used to. And without that physical prompt of touching the money and knowing what the coins are and knowing the value of it, it makes their understanding of transactional operations really much more complex for them, because everything is then abstract. If we're just doing it on an octopus card, it just becomes an abstract piece of maths rather than an appreciation of value. So those two things are quite different. So the more you can get your children physically handling money and talking about what happens when you give over a $10 bill and you get change for something that costs $7.50, then it's a very different learning process. It's something that we would highly recommend you do as much as you can of with the children.
Yeah, I totally agree, Susan. And it also kind of links to their appreciation of money too, because we talked about in year 6, we're looking at big numbers. So we're looking at apartment prices, and they're realizing how expensive it is and how little you get for your money in Hong Kong. And we were looking at different cities across Asia and the house prices there. And I think it's been a really great learning opportunity for the children to realize how much you get for your money, what your money is worth, and how much money you need to buy something, which I think has been really interesting. So we talked about baking, we talked about money, and we talked about board games. The last two then is maths in the news. For the children to see maths in the news and to talk about what those numbers actually mean. So again, rather than seeing them as an abstract thing, or that looks like a big number, but I don't actually know what it means. Having an understanding of rounding as well. We were talking today in year 6 about the use of rounding in newspaper headlines and why we use it, why we don't put, $9,857. We say $10,000. And then the last thing then is time. Just that everyday application, seeing maths as part of everyday life, asking the children to tell you the time, using the digital clock. Have they got a watch? Do they have access to actually knowing the time? Do they know how long before the next something or other? Are they able to read their school timetable and know how long they've got before the next lesson? That kind of thing is really important. Okay, so they're all real life connections that can be made at home. And then the last thing then is online platforms. So the online platforms that we use within years 3 to 6 are Manga High and Times Table Rockstars. So homework, when we go back to giving homework, online learning, they will be doing Manga High, and that will usually be one piece of homework a week, maybe 1 or 2 activities. And to log on to Manga High, the links will be clickable when you get this PDF. The school ID number is there, and they just use their S number and regular password, and that's the same for Times Table Rockstars. Now, it might be that the children are being set this as homework, but these are actually open activities for both of these. They don't need to be set activities to go on these websites. They can just be doing it because it's gamified and it's fun, and they're actually an open plethora of things that they can be doing on those websites to build their understanding, to build their fluency and their procedural knowledge. And if you remember from our 3 types of knowledge, there are those first 2 steps. So these are really great websites that build children's confidence, they make maths fun, and the children feel like they're really getting something out of it. So
I had a question about that. There's a question that fits directly into what you've just said there. On the previous slide, you'd mentioned the 3 stages of basic knowledge, procedural and conceptual, and there was a question around, could you explain a little bit what you mean by conceptual understanding in maths?
Yes, of course. Okay, so in terms of conceptual understanding in maths, if we talked about something, for example, like place value, so the fluency side of things is just being able to tell us the value of the hundreds, the tens, and the hundreds, the tens, and the ones, or the thousands, the hundreds, the tens, and the ones. That's the fluency, knowing what each number means. Then you have the procedural. So, for example, you might be given a number, and you have to label the value of the 3. So, but you have to work out what the question is asking and what you need to do. And then the conceptual understanding might be, you are given 4-digit cards. Can you make the biggest number possible? So to build the conceptual understanding, you have to have that procedural knowledge, you have to have that factual knowledge, and then you have to link it to what you already know. So it might be that you are asked something specifically to do with place value that then links to statistics, or it might be something to do with place value that links to estimation. So with conceptual knowledge, it's checking that you have a full understanding of what's being asked of you, and you might be asked to reason, you might be asked to explain. So it goes beyond just working out what the question is asking, oh, I need to use this operation. It's actually realizing, oh, there might be more than one way of doing things. For example, with the 4-digit card option, for example, saying you've got 4-digit cards, what's the biggest possible number you can make? And then going, okay, what's the smallest possible number you can make? And then having a kind of logical order, a way of doing things. I hope that answers that question. Susan, are there any other questions? Because this is the end.
There is a question here about pre-assessments and post-assessment, but while we were learning online, was there much use of the pre-assessments and post-tests when the children were learning from home?
Okay, so I know in years 3 to 6, every year group did do a pre-assessment, and I believe they did a post-assessment. They did do a post-assessment for those that have finished the units already. Now, because we've only recently discussed with the maths team, those post-assessments were done quite soon after the unit had finished. But when we go back to school, we will be following that structure of the pre-assessment being right at the beginning and the post-assessment being done 2 weeks after. Now, because it wasn't necessarily set as a test, you might, as parents, not even have known it was a pre and post-assessment. But if you were to go onto your child's seesaw, for example, there might be activity where it said, show us what you know. That would most likely be the pre or post assessment. The teachers didn't label them as pre or post assessments on Seesaw for the reason of the children thinking like it was a test that they had to perform. It was more a case of just seeing what they knew already.
Yeah. I think that's a key point, and it's something that we're asked quite a lot, because obviously we've got our year 3s and 4s back in school now, and next week we'll have the 5s and 6s as well. But in terms of that more formal assessment process and making sure that once the children are back in their classrooms, we have a really solid and sound understanding of where they have made great progress, perhaps where some of the gaps might be in their learning, and therefore thinking about how we plan to go forward to close any gaps if they are there, and to build on the knowledge that the children have got. We'll be doing those a lot of assessments in the first few weeks, just to make sure that we have a very clear baseline and we know exactly the starting point for all the children, so that we can move them all on and make sure they haven't missed out on anything while we haven't actually had them here in school. But we're confident that they've made good progress, and the assessments that have been happening, some have made probably arguably slightly better progress, I think, because they've been so well supported at home, and actually having that one-to-one support from parents for a lot of the children has made a big difference. So we will be doing quite a lot of that when we get back, so that we are very clear about what the individual needs are and how we support those going forward. There weren't any other questions written, so if anybody has any questions, do feel free to ask them.
I feel like I want to see everybody's faces now too.
Well, there is another one. Primary, I was forced to memorize all the times table. It made it easy, so I've been trying to make my daughter do the same. But that's not always easy, is it? We're asking our own daughters to do things. I think memorizing times tables, and I think we talked about this before, is an important part of learning. Sometimes they're boring. Learning things repetitively like that is boring. But when they're understanding of the reasons why it's important to know them, it isn't just about being able to score points on times tables rock stars. It's about understanding, you know, your times table. You can then use your mental capacity to solve the problem rather than think about what's 7 times 7. You know the answers. So you can then use the rest of your brain to solve a problem, but also that you understand that 49 divided by 7 is 7. So it's the reverse number. That when you truly understand what's important and where it's useful, that can certainly help. In terms of forcing children to learn something, that can be very difficult. Bringing them into that positive space and like touching the red button, confident about and realising their successes. I don't know of a child in the primary age child who doesn't remember the words of the song that they particularly like, and we do a lot of learning through song. That's a strategy if you don't want to have extra screen time, which I completely understand. Learning time so that you just know them without really thinking about them. Or the other incentive is you know them, you don't have to relearn them. Once you've learned them, and what I did with my own now in year 12, so he should know it now. But we had a competition because I know he is really competitive, and the competition was always, can he beat me, or can he get more time for questions right than me in a certain time, or through a certain methodology of doing that. But that worked well for him because he was delighted when he could start to beat me on those things. So you know your children best, but pick any method with them. But actually sometimes as well, explaining to the child, actually, this is a bit boring. And the sooner you learn your times tables, the sooner we move on to the really interesting stuff. And the way we use that knowledge, that becomes hugely interesting. And that can be a motivator in itself as well.
I would also say with times table, one of the strategies that I found with some children who aren't really getting it yet, is using cards. So like flashcards, where you have the flashcards on the table and you get them to match the times table fact to the answer, doing that and making it a game. Or doing, where you turn it over and you have to match it, like a memory game where you have to match them. Or even doing it as a flashcard, and if they get it right, they get to keep it. And it's just that repetitive thing. Now, if it, don't want to gender, but if it is a girl and they want to decorate their flashcards and they want to create their own collection of flashcards, that's also something, because they're motivated, because they're theirs, they own it. That's quite a nice way of doing times tables, because it's something, oh, let's go and get out your flashcards for 5 minutes, let's do a quick practice. And then just that regular times table practice will embed, and then they'll feel more confident. Susan, are there any more questions?
Not that I can see. Just if there is a request that if there are any more questions and I'm speaking, you turn off your microphone to stop the echo. And some shared ideas and thoughts about how to support children at home. I'm looking to see if there are any specific questions. Oh, is DBIS also using Singaporean Maths Mastery in its curriculum?
Okay, well, we use Maths Mastery as a concept, but we're not necessarily using the Singaporean Maths Mastery approach. I don't know if you want me to go, should I go into more detail, Susan?
I don't think you need to. I think answering it by saying that Maths Mastery is hugely important and something that we do place considerable value on. But the teaching of a particular scheme or a particular approach isn't something that we adopt. We base all our teaching and learning on the expectations from the English national curriculum. So there is a rigor in terms of what the expectations are, but how we deliver that, the context through which that learning takes place, is something that makes DBIS unique. So we're very proud of this and the approaches that we've developed here at the school. We know they're successful, but we don't necessarily align ourselves with a particular style of teaching or a particular model. We have children coming in from all over the world with different backgrounds and different ability levels and different exposure to the curriculum at different stages. So to be drawn into one fixed approach like that isn't something that's going to benefit the majority of them. Well, I think that's the questions that are on there. Nice between parents, so thank you for sharing that. Like Katrina said, we will share this with you on the parent portal tomorrow. We'll share the slides and the recording. So if you have, if you're aware of other parents who might want to have a listen and see what Katrina, the information Katrina shared with us today, then please recommend that they do so. Thanks very much for your time. We know it takes time out of your day. It's quite nice to be able to do it, that we're not having to travel everywhere in that respect, but I do appreciate it's a little bit more time in front of the screen, and we all have plenty of that at the moment. But I hope you found it useful. We're very grateful that you're interested enough to want to learn more about it. If you have any more future questions, of course, please don't hesitate to email myself or Katrina, or to speak to your child's class teacher. They'll always be very happy to help. But thank you very much for your support going forward.
Yeah, thank you, everybody.
Thank you.
Thank you.
Thanks.
Bye.
Bye-bye. Thanks very much, everyone. Bye.